All right. So let's move on then to the next polyhedra with a specific, more specific name. Okay, it's very similar to a pyramid in that all the faces are polygons. Okay, however, it differs in some respects as well. So a prism is a polyhedra. With two parallel and congruent bases. Congruent just means equal in all respects. Because it's a polyhedron, those bases are polygons. And they're connected by parallelogram lateral faces. And now, when we're dealing with right prisms, and all of these diagrams here, these drawings are right prisms, and the parallelogram lateral faces are all rectangles. So in a right prism, the faces are rectangles, not just parallelograms. And like I said, most of the ones that we'll be doing will fit that description. Okay, the historical definition is it's a solid figure contained by planes, two of which are opposite, equal, similar, and parallel, while the rest are parallelograms. Okay, so that's again interpreted more commonly in this fashion. Okay, just like pyramids, a prism is classified by the shape of its base. Okay, except here now there's two parallel and congruent bases versus the pyramid's one. Okay, so if we looked at this first example, what shape is our base? So you have a rectangle, so this is a rectangular prism. Okay, so what's to keep me from saying that these are the bases? Are those parallel and congruent polygons? Yeah. Are they connected by parallelograms? Yeah, so that pair of these red faces could also be considered the bases of this prism. Would it still be considered a rectangular prism? Yeah. Okay, what if I took this front and this back face? Are those parallel and congruent? Yeah. Are they connected by parallelograms? Yeah. So the one thing unique to rectangular prisms is any set of opposite parallel and congruent bases or faces could be considered the bases of that prism. And that's not always the case. It's only on a rectangular prism. Okay, so what would be the name of this second example? Hexagonal prism. The next one is a trapezoidal prism. And the last one is a triangular prism. And so if I were to sketch the following. Okay, would this figure be considered a prism? All right, so somebody who says yes, what would justify that? Are there two parallel and congruent polygon faces that are connected by parallelograms? Okay, so if I looked at this top and this bottom, are those parallel to each other? Yes. Are they congruent? No. So it's not a prism based on those two. What if I took these two sides? Are those congruent? Probably in this case, it kind of looks like they are, but are they parallel? No, so it's not a prism based on that pair of opposite sides. And what if I took the front and the back? Are those congruent? Are they parallel? Yeah, so are they connected by rectangles? Yeah, each of the lateral sides. Here's one rectangle, second rectangle, third rectangle, and then the bottom, a rectangle. So this is considered a prism. What shape are the parallel and congruent bases? And so this also is a trapezoidal prism. One of the unique things that you need to be able to see, and you probably have never really been exposed if you're looking at solids in any of the lower levels, is that the bases don't have to be top and bottom, which is what most students will kind of think. The bases can be front and back, as in this case, or it can be left and right sides. Okay? So don't think just in terms of the top and the bottom. And you can still have the other types. Right, so just like a pyramid, a prism does have a height or altitude. The height or altitude is the perpendicular distance between the parallel and congruent bases. So in this case, we could have our height here. Again, we could have had the height be this measure, or we could have had the height be the distance between these two bases as well. And here, our height or altitude is the perpendicular distance between the bases. Here's the perpendicular distance between the bases. Here's the perpendicular distance between the bases. And in this example, the perpendicular between the bases is this side distance. Okay? Olivia.